Hello, everyone. My name is David Jeshvili. I'm VP Product and co-founder at Drone Harmony. And I'd like to welcome everybody to our webinar, Deep Dive into Planning in Drone Harmony. Thank you, everyone, for being here. Thank you for taking your time out of your busy schedules. We're very happy to see so many of you here. I will be co-hosting with Janine Stoll, who is a marketing manager at Drone Harmony, and she'll help me with Q&A and other logistics related to the webinar. So the webinar is being recorded and we will share the recording with everyone here, and we encourage you to share the recording with other colleagues that you think might be interested in the content of the webinar. In case you don't know, we also have a webinar on how to start working with Drone Harmony, and I will later show you where to find the recording of this webinar, as well as other resources that you might be interested in if you intend to work with Drone Harmony in the future. Towards the end of the webinar, which we planned for about 40 minutes, we will have a Q&A session, and we encourage you to ask questions in the Q&A box in the Zoom window. You can ask questions at any time, and my colleagues here might be answering some of the questions during the webinar already in text, and I'll be answering some of the questions towards the end of the webinar. Okay, so let's dive straight into it. So what's the content of the webinar today? As I said, we're gonna take a slightly deeper dive into the planning workflow in Drone Harmony. And these are kind of the learning goals for today. So first off, we'll make a fast recap of the platform and the workflow for those of you who would like to have such a recap or that have not seen the workflow before. We will talk about slightly more advanced features of mission planning in the web interface, and we'll focus a lot on the mobile application. In particular, we'll touch upon cell tower inspections and how a skin in the mobile application of Drone Harmony can make it easy for you to plan and execute flights for inspecting cell or communication towers, as well as working with terrain data. We'll show you how you can import terrain data into the mobile application and use it to plan terrain-aware flights. And as much as time will permit, we will discuss slightly more low-level issues like how to edit waypoints using points of interest as much as we will have time for. So this is kind of the overall plan for today. And we really want to focus more on the more advanced features in Drone Harmony here. So cell tower inspections and working with terrain, and some more advanced tricks in mission planning. So those are kind of the main goals, but we will also touch upon the main aspects of the platform and the workflow for those of you who are not familiar or need a recap. Okay. So just a very quick recap. So Drone Harmony is a platform that enables digitizing complex infrastructure assets. So it's a software platform with a mobile application, web application, and the cloud. Those are the three main components. And all of the components kind of work in unison together through synchronization through the cloud to enable you to easily plan flights for capturing high quality data around your infrastructure assets. So as I said, today we will discuss the web and the mobile as well. And we'll remind you that the cloud is there to help you communicate and share information within the organization. Okay, so let's just jump into the first demo. As I said, I will touch upon the workflow real quick. So the first demo will be a quick one where I'll remind you how the workflow in Drone Harmony looks like and what planning missions in Drone Harmony entails. And then we will go into the more advanced demos. So this one will be in the web interface. Let me switch over to the web interface real quick. So I remind you that you reach the web planning application of Drone Harmony by navigating to app.droneharmony.com. And now let me just full screen for now so that we have the best view. So the first screen, as you may remember, is kind of a map view. We have choices of maps here on the top right that we can pick from. Let's stay with Google Maps Hybrid for now. And I'll very quickly go over a planning workflow so that we have the main concepts in mind, concepts of a scene, a plan, and plan generation based on a scene. So I'll start off by loading an existing site, and I'll go ahead and load this building complex site, which, as I see here, based on the tags, is somewhere in Bern, Switzerland, and has some facade inspection missions in it. I will load the latest. You remember maybe from previous webinars or other material that we can also load an older version, an archived version, but I'll load the latest right now. So here we have our scene. So as you remember, in map view, we will always see elements of our scene as overlays on the map. Those are these polygons that we see right here, as well as some missions. So I can highlight missions by placing my mouse over them, and I can also pick them and do some editing and so on and so forth. So we will not go into much depth about this right now. So what we will do is we'll plan a mission. So first off, this is our view in 2D. Let's take a quick look in 3D, how the whole thing looks like. And this is a quick recap. In Drone Harmony, we have two main interfaces, the 2D that we have just seen, where you see everything from the top. And we have a 3D view, which illustrates the actual data that we're using in Drone Harmony to plan our missions. And this is 3D information. So you see here a model of certain buildings, and we are performing some mission planning for capturing data around this bright blue building here, and a little bit about around the darker blue building here. And this scene here represents kind of the information that we want our mission planning engine to know when we automatically generate missions. What we also see is we see a bunch of missions here, all of them together. Let's just turn some of them off so that we can be able to see, so that we are able to see just one. So here is one of the missions that we have, and we can again navigate and look at this mission from all angles in 3D, and also of course in 2 dimensions. Here it is right here. So let's say that our goal for this planning is to inspect the facade of this bright blue building again. So let's go again in 3D. So let's say we want to inspect the facade all around this building, and just let's see how this workflow looks like. So you know that we've created the scene before, and we've seen various ways of doing this in the first webinar. Now we just want to create quickly a mission. So I go over to this plus icon over here. Let's quickly remove this. Okay, let's go to the plus icon over here. This is my access to the plan catalog. And here I can pick among several types of missions. I can go to my inspection tab here and pick, for example, perimeter verticals. So I pick perimeter verticals. And then I have to choose what structure, what asset in my scene I want to apply to. So we've already discussed that we want to apply to this blue building over here. I choose it and tap continue. Next thing is to pick a lift-off position. Let's say we would like to do it from this grass field over here. And I press continue to start my mission planning. As you can see that once I've done this, I'm already in this kind of dual view. On the right, I have a representation of my scene. I can see what's happening, and I already see an initial suggested plan that Drone Harmony is suggesting to me. On the left, I have parameters I can adjust. Let's just make some adjustments. Let's say that I want a lower side offset, let's say 11 meters from the building. What you can see is that we already have some adjustments on the density of the waypoints, because for the same overlaps and at this distance, we need more points. And let's move over now and change parameters that will enable me to capture the entire circumference. So, okay, overlap, we can play a bit with the overlap parameters just to make it a bit less dense in case we're not interested in modeling the facade, but just capturing some good data around it. And let's go to coverage. So the coverage tab tells me what part of the circumference of the entire building I want to cover with my mission. So let's say let's go and drag this coverage slider over. And you see that the more I drag it over, the more parts of the building get inspected. And it's also critical to note here, and this is a great example to illustrate this, I only get parts of the building inspected that can actually be inspected considering the obstacles that I have in mind. So the mission that is generated considers the scene for obstacle avoidance, for planning obstacle avoidance. So let's say that I want the entire circumference. So let's pull it over all the way to 100%. And you see that I have a nice little belt all around the building wherever possible to inspect the facade of this building. Okay, if I'm happy with this mission, I can generate the mission, and here I have it. I can now synchronize it. Let's quickly do that. I go to my menu, save site, and I can give it a new name. Let's say building complex with new facade, and I can save it. So now this mission is saved, and I can load it in a mobile device to start executing this mission in the field. Okay, so this was a very quick overview of the planning workflow in Drone Harmony, just as a reminder. We have a so-called scene-based workflow. What we do in the first stage is always to define a scene, which is this 3D model of the world. And later we plan missions for that scene. When we plan the missions, we can save them, and we can then start executing them in the field using our mobile application. So that was just a quick recap of this. Okay, so let's jump back into our presentation and continue. So the next demo that I'd like to show you is that of cell tower scan. So what is cell tower scan for? So cell tower scan is for digitizing cell towers or communication towers. And before we go into the application, just a few, just to give you an idea of what kind of deliverables we can expect from a workflow of, where we digitize a cell tower. So different customers of Drone Harmony and different users have different goals for the data that they capture using cell tower scan. But here's a very interesting example of creating a 3D model of the cell tower. And you can see that the model can be very, very nice and accurate. But to create such a model, you really need a very good data set around your cell tower, because actually modeling cell towers is a challenging task. And capturing data around cell towers is also a challenging task for various reasons, because of the small components that you have around the cell tower that if you want to model, you have to have very high resolution imagery of, as well as the fact that the cell towers often have, let's say, a texture that's not very favorable for modeling. So one really has to be very, very careful about what data one puts into the photogrammetry workflow. So creating 3D models can have various applications. We can use the 3D model to navigate a nice image set of the cell tower. We can click on different images and know where on the cell tower these images were taken. They can be used to measure aspects on the cell tower, and they can even be used by the sales team of the cell tower owner to sell different parts of the cell tower for other companies that want to install new antennas, and so on and so forth. So modeling cell towers is one important application of cell tower scan, and we will go into how to use cell tower scan immediately. So for this, what I'll do is I'll stop sharing here and I'll switch over to the mobile application. Cell tower scan is a skin in Drone Harmony Mobile, in the Plus version of Drone Harmony Mobile. So let me stop sharing here. Okay. So here I am in my mobile device, and I'm working with Drone Harmony Plus here. And as you can see, I currently have not much on on my screen. So the first thing I'll do is I'll switch over to cell tower scan. So Drone Harmony Plus comes actually with two different applications in it, and we call them skins. So if you see this tool set on the left with the polygon tool and all of that, this means that we are actually not in cell tower scan right now. This means that we are in our inspection skin. So let's switch over to a different skin. So to do that, I'll go to the menu on the top left, and I will go to Account and App and change App Skin. So here you can see that I have a choice between Tower Scan and Mapping and Inspection. Currently I'm in Mapping and Inspection. I'll switch over to Cell Tower Scan and I will approve the restart of the app. Okay, here we are in Cell Tower Scan. And you can see that we have kind of a different tool set. It does look similar, but we don't have the tool set on the left. And the reason for that is that Cell Tower Scan is slightly less general. It's tailored for a very specific use case. And for this, we reduce the tool set that's available to the absolute necessary set of tools. And this really enables the workflow with this application very, very easy. So first things first, let's start with a ready scene and see how we can learn about the application from looking at a ready state. And after that, we will build up the same or a similar state by just going through the entire process. So let me go over to the menu here, and I'll go to Plans and Flights, and I will load a state. So you see that cloud synchronization has changed something and actually downloaded my building complex with new facade here, the mission that we have created now, the scene that we have, the site that we have created in Drone Harmony Web. So what I will do is I will load Cell Tower Zurich, this state over here. So when I load this, you see that we start seeing similar and familiar things to us. We see some overlays in the map view here. And we see some missions here on the right. So I can click on one and it tells me that it's some sort of mission called Dome Orbits. And if I click on the other one, I see that it's called Tower Verticals. So as usual, to understand what's actually going on, let's switch over to 3D. Okay, let's move this over here. Okay. So now I'm in 3D, and what you can see is that in 3D we have a simple but accurate enough model of the cell tower that we're planning to inspect in here. And this is a model slightly different from the types of model that we've seen so far. We have the familiar block structures here on the bottom, but we also have a specific structure that's representing the cell tower itself. This is this tower in the middle, and it has some rings on it, and these rings represent antennas, where antennas are mounted on the cell tower. So let's look at missions now. So we have Tower's Vertical chosen here. So let's see how a Tower's Vertical mission might look like. So we're just simulating the mission. And you can see that I can simulate it by going, by sliding over this slider from left to right. And you see that this mission flies up and down the tower and all around it. And here we can capture high resolution imagery this way. We can also capture video, but the more common use case is to capture images. And this kind of image set is very useful to cover the entire tower with very high resolution images that we can afterwards navigate conveniently, or to create a 3D model of the tower. So let's look at another type of mission that we have here, which is called Dome Orbits. So the Dome Orbits is a mission that captures data only from the top part of the tower. So I'm simulating it now. So you see that it creates several orbits, and the orbits all face kind of the top point of the tower. They're getting smaller and smaller and higher, and all of them are always focused on the middle of the tower. And the reason why we might want to capture data with such a mission is that this kind of data is very useful for photogrammetry. It captures very good imagery of the top of the tower, which is a place where we often have very important information about the tower that we want to have very good imagery of. And B, it captures data of the tower together with the ground station of the tower and the base of the tower. And this enables photogrammetry to afterwards stitch both the tower and the ground station together. So in common photogrammetry workflows, we will use image sets that combine something like a tower's vertical and a dome's orbit that we've seen so far. Okay, so this is quite familiar. As usual, we have a scene. A scene is simply a 3D representation of the asset and the environment, some obstacles, and we have missions. And this together is a state in cell tower scan as it would be in any other drone harmony application. Okay, let's go back. So what I'll do now is I will clear the state and we will go through the process of creating it so we know how we can plan cell tower inspection missions. So for this, I'll go to the plus, and here in this application, the plus contains not only the plan catalog, but actually the entire set of tools that we need for cell towers. And in this case, you see that I can search a location, clear the state, which I will do right now, edit my cell tower model, and create a flight plan. And what you will notice is that we don't have generic tools to create scene objects here, but rather we have a wizard, and we'll very quickly see the wizard for creating the model. So let's clear the state. We'll clear everything. So now let's zoom in here, and you see here I have my cell tower in the middle. You might ask yourself, how do I know where it exactly is? And the answer to this is that you actually don't need to know where exactly the tower is. You need to know it approximately. The reason for that is that the application, when you execute the flight, it will make you go through a so-called calibration flight. The calibration flight will enable you to use the drone to position the location of the tower very accurately. And this is very important when you do something like a cell tower inspection where you fly several meters away from a tower. It's very important to perform the calibration. This calibration accounts for modeling errors that we incur when we create the model of the tower, as well as with the inherent GPS inaccuracy and shift that the drone's GPS might have. So both of these things are accounted for using a calibration flight. But I will not go into great detail into calibration in this video, in this webinar. What I will do, however, is I will show you how to create a model. And all of this prelude was just to tell you that creating the model, especially when it boils down to setting the location of the tower, you don't need to be very, very accurate about it in the modeling stage, because we have a way to overcome this inaccuracy in the execution step. Okay, so let's start by modeling the tower. So as I told you, all the tools here will be available through the plus button on the bottom right. So let's go over there and let's input the cell tower. So the first question is placing the center of the cell tower. So I placed where I think the center of the cell tower approximately is. And we've now discussed that we don't need to be able to find this place very accurately. In fact, in some cases, you won't even see the cell tower on the map, but you will still be able to use cell tower scan if you know just approximately where the center of the cell tower is, because of our calibration procedure that you go through when you execute a flight. Okay, so we placed where we think the center of the cell tower is. Let's tap next. The next thing we can do is we can outline obstacles. So here we have a polygon tool that appeared on the left, and we can use this polygon tool to roughly outline here, for example, the tree line that is relevant for the flight. And let's outline this structure over here that I know is a hut that's a bit higher than what I see here in the map. And let's also outline this bunch of trees over here, because I know there are higher trees than the other trees. Okay, and let's say these are all obstacles that I know will be relevant for this particular flight. So when I'm done with that, I tap on submit. And as I tap on submit, I enter what's called the planning wizard for cell tower scan. And here It's very similar to planning a mission, except that here we're populating information about the model of the tower on the right-hand side. So first things first is I can enter information about obstacles. So first off is the bright blue obstacle, and I know it's 3. So let's change its color to green. And the height there is about 7 meters of the tree canopy. Next thing is the building, and I think that one is about 9 meters. And the higher trees are much higher, so they're 15 meters above the ground. Let's give them as well a color that suggests these are trees, just for my visual feedback to know what the obstacles represent. Okay, so here we have the beginning of our model, and you see that we have kind of the tower already, some representation of it there, and the obstacles are already done. So now I can switch over to the next tab, and this is the tower tab. In the tower tab, I can give my tower a name. Let's just call it tower for now. And I can give the height of the tower. So I know that my tower here is 80 meters, and I can also give it a radius different from default radius 2, but 2 is fine for this tower. Okay, the next thing is I'll switch over to the tab called antennas. And in the antennas tab, I can input information about where the antenna batteries are on the model, on the tower. So at 75 meters, I have some battery of antennas that in the horizontal direction sticks out 3 meters, and its vertical dimension is, let's say, 4 meters. And you see that I already have representation of this appearing over here. This is this violet battery of antennas. Now, let's say that at 70, I also have some antennas, and I'm not being particularly accurate about this right now, because what you would usually do is you would look at a CAD model of the tower because you were given such a model by the company, or you own the tower yourself and you have this information, and there all of these heights and thicknesses will be available. In other cases, you might need to measure them perhaps by flying the drone up and down. But here, for the sake of the demonstration, I'll just input some information. So let's say at 65, I have another battery just for the sake of it. It's a bit thicker like that. Okay, so I inputted all of our information about the tower now, and you see that I very quickly have a very nice model that's really good enough for mission planning, but it enables quite good and accurate mission planning. So let's tap on submit. And here's my tower model. I have it in 2D, and I can look at it in 3D, inspect it, and if needed, make edits, no problem. So next thing we'd like to do is perform mission planning. So let's go and tap on the plus again, and this time choose create flight plan. And in create flight plan, we have again a plan catalog, just as is in other Drone Harmony application, whether it's web or mobile, except that here, since we're in cell tower scan, all of our plans are tailored for inspecting cell towers and nothing else. So you'll see here 3 tabs with different types of missions. And no, I didn't want to choose that one yet. So let's go back, create flight plan. So we have a bunch of them here, and we have some additional ones over here. And let's pick one of the basic flight plans here. And basic is, you can think about basic flight plans as patterns that kind of cover the cell tower from all directions by flying in different patterns. So I'll choose tower verticals for this demonstration. So let's choose tower verticals. And once I choose a pattern, the rest of the workflow is really nothing different from the usual Drone Harmony workflow. I need to pick a lift-off location. So let's say here in the grass. And then I enter the planning wizard as always, and I can choose some parameters. For example, distance from the tower. I can make it a bit bigger, let's say 6.5 meters. And I can choose a certain number of verticals that will correspond to overlaps. So let's say I would like to have a bit more horizontal overlap, let's say 85%. One thing to know about inspecting cell towers, if you're going to make a 3D model, you really want to have a lot of horizontal overlap. So we recommend at least 16 verticals if you're working with the tower verticals mission. I can choose the gimbal angle. Here too, we have some recommendations. So it's good to be facing the tower as directly as possible. However, you run into the risk of facing, in some directions, facing the sun or strong light, which can mess up a lot of your images. So perhaps keeping the gimbal angle, some angle in the range of, let's say, -10 to -30 is a good choice. Of course, the more you face down, the less detail from underneath the antenna batteries you will be able to capture. Okay, and we can control parameters as we can control parameters in any other application. And we can now generate this flight. And here we have it on the right-hand side, a mission that's ready for us to start executing. So let's go to 3D and quickly take another preview of this mission. So we created this perimeter, this tower verticals missions here. Okay, so that's pretty much it. The only real difference in cell tower scan compared to the mapping and inspection scan is that here, to create a model, you go through a wizard that quickly tells you what parts of the model to input at every state, and it really quickly enables you to create a nice little model to automate the plan generation based on it. Okay, so this was my demonstration of cell tower scan. As I said, it's just another Drone Harmony application, except that it's tailored for inspecting cell towers. It has exactly the same workflow, the scene-centered workflow, where we create a scene and then automatically plan flights on it. And the only difference is how we create a scene. And this is done through this wizard that we have built in to the application. Okay. So let's end this, this demo here. And the next thing I'll do is I'll touch upon terrain, how to use terrain to perform terrain-aware flights. So to use terrain, we will switch back over to the mapping and inspection skin within the Drone Harmony mobile application. So again, I'll go to Account and App, change App Skin, and I'll go to Mapping and Inspection this time. Okay, so here we are back in the Mapping and Inspection skin with the familiar tool set on the left and access to the plan catalog on the bottom right with the plus icon as we've seen before. So the first thing is if we want to work with terrain, we need to have a terrain file on the mobile device. So I currently have a terrain file on the mobile device. So I'll show you how I can import this file into the application. So for this, we go to the menu, go to Import and Export. And among these import and export options that you see here, one of them is Import Terrain. So let's go ahead and tap on Import Terrain. So we enter this window over here. And the first thing that we can do is we can actually import a terrain. So at the moment, it tells me that no terrain was imported so far. If terrain were imported into the application, you would see a list of the terrain files here. So let's go ahead and import something from the file system in the device. So I tap on the bottom right, and this enables me to start importing a terrain. So let's give it a name. So I'll just call it terrain, and let's locate the file. So here's my terrain file, this terrain3.asc. I'll choose it. And as soon as I choose it, you see the application starts processing the file and making it ready for me for loading it into the scene and to start planning missions. So we're almost done. And as soon as we will be done, it will appear here in the list. And here it is. So it's called terrain, as I named it, and it has about 100,000 points. So it's a point cloud. And we will use this point cloud to perform terrain-aware flights. So to load the terrain into the scene, I'll tap on this down-facing arrow near the terrain file. Okay, and here we are. So what we see here is we see a polygon, unlike other types of polygons that we've seen before. overlaid over the map. So this light red polygon that's overlaid is displaying to me where I have terrain information. And I can now, within this red area, I can start planning terrain-aware flights. So let's see how this works. So the first thing is I need to use the polygon tool. So I'll choose the polygon tool and I'll outline some area in which I want to perform a terrain-aware flight. Let's say I want to perform terrain-aware flight in this area here. Let's give it a color. Let's give it a green color. I can edit this shape as usual. And the first thing I'll notice is that there is an icon that's appearing on top of this polygon, and it will appear every time we perform, we construct a polygon within a red polygon representing terrain. And what this enables us to do when tapping on it is to create a terrain surface for this polygon. And we will say compute here, and we'll allow the application to create a terrain surface for us. So the terrain surface is almost done. And as soon as the terrain surface is generated and I get this nice message, I can switch over to 3D view to look at the terrain surface that was generated for me. So here it is. So you see that it has, vertically, it has exactly the shape of the polygon. And what it did for me is it actually triangulated the point cloud underneath this polygon into a terrain model that I can now use to perform terrain-aware flights. And I can interact with this in terms of visualization the same way as I can with any other model in Drone Harmony. So I can look around, I can take a look. So you can see that it's quite a detailed terrain model because I can even see, so actually it's a DSM, it's a surface model because I even see houses in here and I see treetops and so on. So I can actually find many different elements of the surface around here based on this particular terrain file. But one can input a DEM, so the digital elevation model, or a DSM. It doesn't matter. The application will work with any, as long as it's a point cloud in the format that's supported. Okay, so let's go back and start planning a mission. So to plan a mission, as usual, we tap on the plus on the bottom right corner. And here you can see in the plan catalog that we have the terrain-aware flights now available for us for choice. So let's choose terrain top-down. Terrain top-down is a pattern that is very similar to top-down. It's capturing images from above, but it's tailored for terrain. So it's following the terrain. So let's choose terrain top-down. The next thing, as usual, is to pick a liftoff location. Now, for terrain-aware flights, we only are able to choose a liftoff location within the terrain polygon. So let's choose a point here. The reason for this is that if we were to choose it outside, there would be some risk involved in not knowing if there is terrain data available for this outside liftoff location, and we wouldn't know the relative altitudes from that particular location with respect to the place where we do have terrain data. So we do need to choose a location within the polygon. So let's submit this one. And we enter this kind of planning wizard as we usually do in Drone Harmony. And first things first is to determine a flight altitude for a mission like this. So let's say 30 meters. So as soon as I choose 30 meters, you see that I have a nice little terrain-aware flight that's already been generated for me. And the rest is just as usual. I can control overlap parameters into overlap tab. I can make the overlaps a bit smaller in one direction, a bit bigger in another, whatever I need. And as soon as I'm done, I can just generate this flight, and the flight appears on the right-hand side here. And I can start working with this flight. I can start executing it and so on and so forth. As usual, I can go into 3D and take a closer look, and I can simulate the flight and see what the progression of the flight will look like. You remember that we also have a first-person viewer in 3D. In some cases, it's useful. We can even take a look in first-person view here to simulate how this flight will look like if we think it's valuable. And Let's go back to third person view. And that's it. We're ready with the terrain, nice terrain aware flight that we can use to map this complex environment over here. Okay. So that ends my third demo on terrain aware flights. And in terms of file formats and how to make sure that your file will be compatible with Drone Harmony, I will later show you some resources online where you can read about what file formats are supported and how to use it. One thing I just want to say on top of that is that terrain aware flights is something that we're working now on making available also on the web interface, and it will be a much more powerful tool set that will be made available for you to work with terrain. In particular, through the cloud, you'll be able to work with bigger volumes of terrain and to perform more complex mission planning. So that's just something about what's coming up in the future for the Drone Harmony platform in the space of terrain aware flights. Okay, so let's now quickly switch over back to the computer. So I'll stop sharing over here. I'll start sharing again on my computer. Okay, so so we've seen a cell tower scan, and we have seen terrain aware flights. So the next thing that I would like to touch upon a little bit is editing missions, and that will really be the last little demo that I'll do for you today, and then we'll be able to switch over to the Q&A. So editing missions, I'll show you how to edit missions first off in the web interface a little bit. And what I really want to do is I want to touch upon the low-level waypoint editing features that you might find useful, because in many cases when we generate a flight, it's very, so 99% of it is perhaps perfectly what we need, but there are a few waypoints that we need to edit because we forgot to input some obstacle or because we realized that we want to have a slightly different angle at a certain part of the asset. So what I'll show you now is a few easy tools that you can use to adjust missions very easily within the web application. And very similar tools are available in the mobile application, but I'll probably not have much time to go into that. So let's switch over to the web interface again. And we will look at, what we'll look at is we'll look at, for example, one of our top-down flights, or perhaps even at this perimeter vertical mission that we have created. So let's click on that mission. And you see that as soon as I click on a mission, I start getting all of the waypoint information about that mission. One thing that I can always do is I can add additional waypoints in between. That's an option that I always have. So if I click on these, pluses that are between the missions, I get new waypoints. I can always undo everything. So let's undo that quickly. And what I want to show you quickly now is what tools you have to edit existing waypoints. So for example, here's one waypoint. What I can do with the waypoint is one of several things. I can drag it around to change where it's located. So the number 30 within the waypoint is actually telling me that it's at 30 meters above ground. Excuse me for that. And so that's one thing that I can always do. And I can also change other things. For example, I can rotate it. And you see that this cone is helping me understand where the camera will be facing at this waypoint. And I can change its gimbal angle and so on and so forth. But as you can see, things like gimbal angle are hard to visualize in 2D. So it's often very useful to switch over to 3D. And you see that we have our waypoint chosen right here. It's this waypoint over here. And when I work with things like gimbal angle, I can really easily understand what's going on if I look at things in 3D. So certain editing options are very useful to do in 3D and others are useful to do in 2D. So in particular, if I'm planning to change the gimbal angle, it's very useful to do it in 3D. I'll quickly see what's going on, whereas in 2D I won't. And the same for the yaw, so the heading. This you do see in 2D, but in 3D you have an even better understanding of what's going on. This is a tool that you can really easily use to adjust some of the waypoints here. On the other hand, moving waypoints around in 2D space, that's really much easier in 2D. So different tools are available in different views, and it's really good to familiarize yourself with what level of detail you can impact the different waypoints and sets of waypoints. So let's undo these changes real quick. And you know that we have a full undo redo stack, so we can go all the way back to the initial mission. And that's the initial mission where we didn't touch this waypoint so far. So now let's undo the selection of this waypoint and see how we can select actually multiple waypoints in 3D. So I can, if I would like to change the heading of, let's say, all of this vertical column of waypoints, there's no problem to do so. I can do this. So I can choose all of these waypoints. I can go to rotate, and I can rotate all of them simultaneously. I can also update all of their gimbal angles simultaneously. So you see that we can edit waypoints in bulks or in single waypoints, and it's really a tool set that's easiest to learn by just trying things out. So I'm just showing you some of the things that you can do easily. Okay, let's go switch back to 2D. All right. Now, the last thing I'll show with regard to low-level editing is just how to use points of interest real quick. So what I'll do here is I will deselect everything, and I'll choose this tool here on the left to create a point of interest, just for us to practice using points of interest. So let's say that there is a point of interest somewhere around, so I'll place it here and then I can drag it over here, for example, around here. And let's say that its height is 20 meters. And let's give it a color that will be easy for me to distinguish, let's say red. So I created a point of interest. And again, in 2D, you can only see kind of the 2D location of the point of interest, but I can switch over to 3D and you see here this point of interest is. I can change its location, I can change its height and so on and so forth here as well. But what I want to show you is I want to show you how you can use points of interest to direct waypoints to them. So what we'll do is we'll quickly show you how to select a bunch of waypoints. Let's say these 3 waypoints. And let's say I want these waypoints to face that point of interest. Well, this is very easy to do. I can go to the right-hand side here in my edit waypoint window toolbar, and I can choose direct to POI. And you see that as soon as I click on this, all of these waypoints start facing this waypoint, this point of interest. And you can really see this by looking at the lines that are exiting these waypoints that are emitted from these waypoints. They're facing directly the red point of interest here. In case I have more than one point of interest, I will be asked what point of interest I want to direct my waypoints to. But in this case, there's only one. So if I click on direct to POI, I will have them all facing that single point of interest that I have. Okay, so that concludes my low-level, let's say, deep dive into editing waypoints in the web application. And unfortunately, I do not have too much time to go into editing waypoints in the mobile application, but a very similar but slightly different tool set is available there as well. You can edit really anything you like. You can make bulk edits, and you can edit in 2 and 3D as in the web application. So it's nice to play around these things and see how you can improve your missions locally wherever needed after generating them automatically. All right. So with this, I'd like to conclude my demonstration, and I'd like to start the Q&A session. So for this, Martin was so kind to prepare some questions for me in a separate slide deck. So I'll just switch over to that one, and we'll start reading some of the questions and answering them. So let me just quickly find these Q&A slides. Okay, so let me start sharing the screen again. And yeah, so we will start the Q&A now, and I'm really grateful to all of you for asking all of these nice questions. Many of them have been answered already during the webinar by my colleagues, but I will answer some of the more some of the open questions and some of the questions that I think are most interesting for the broader crowd right now. So first thing, okay. So first question, this is a really important question. It's related to obstacle avoidance and obstacle detection. So there are several levels of obstacle avoidance, obstacle detection that are relevant when one uses Drone Harmony. One of them is during planning. So we create a scene, and in the scene we include objects that are obstacles, not only the assets that we would like to inspect. So when we do so, we enable the mission planning engine in Drone Harmony to include these obstacles into consideration. So the planned flights are planned to avoid these obstacles. But there is another very important layer of obstacle avoidance available on most commercial drones, in particular on the DJI drones. And this is what I would like to touch upon in this question. How does the DJI obstacle avoidance work when working with Drone Harmony? So there are several things to note. The DJI obstacle avoidance settings are stored on the drone. So that's not something that you store within the mobile application. It's stored on the drone. Once you store them on the drone, these are the settings that are used unless you change these settings in the drone. So you can adjust obstacle avoidance settings in the DJI Go 4 application. And it's very important that you, if you're not sure what your settings are, if you go to that application and set them to what you want them to be. By default, they are active, and Drone Harmony does not interfere with the DJI built-in obstacle avoidance. So it leaves it on in case you left it on in DJI Go 4, and it leaves it off in case you left it off in the DJI Go 4 application. So Drone Harmony does not interfere, nor does it configure these parameters. So the drone will fly and behave according to the DJI built-in obstacle avoidance and the avoidance settings on your drone, also during autonomous missions. So if you execute the mission autonomously, the behavior of DJI obstacle avoidance will be the same as if you were flying it manually, as you set it to be in the DJI Go 4 application. And just a word of caution. So DJI obstacle avoidance is fantastic, and it will save you in many cases when you fly things manually or when you fly close to objects. And it's an important thing to know, but it's still limited. So it's important to always be attentive, and it also has limited range. So it means that obstacle avoidance will only kick in at a certain distance, meaning that if you fly very, very fast, it might not have the time to react. So if you're unsure about the safety of your flight and you're not sure that you have all your obstacles covered, it's advised to fly missions initially slowly and then increase the speed of your execution if you see that the flight is safe. Because if you fly slowly, the obstacle avoidance sensors will often have enough time to kick in and to save you in case something's going to happen. However, you should know that Drone Harmony does not interfere with these things, and if you set the obstacle avoidance on when you work with DJI Go, then they will remain on. Okay, let's move on to the next question. Are no-fly zones available in the application? So no-fly zones are currently passively built into the Drone Harmony application. And DJI maintains a database of no-fly zones which is stored on your drone. So this is important that it's available on your drone. When you fly with Drone Harmony and you would like to take off in a no-fly zone, DJI will realize that and will not allow you to start. So Drone Harmony will inform and warn you when you want to fly in such locations. So at the moment, we do not have a visual display of the no-fly zones, but it's something that we would like to add in the future. And we currently also do not have LANC authorization built in. But we're in conversation with some partners that will enable us to add these things in the future. So the next question, is it possible to display a building on a sloping terrain and then create corresponding flight plans? If so, how? This is a great question. So at the moment, the terrain aware flights, they work with terrain files and do not enable you to add additional structures to them. So the demo that I gave you before, I would not be able currently in the current version of the Drone Harmony mobile application to add, let's say, a building in the middle of that terrain to also include some additional 3D information. In case you need to model some terrain around the building, what we currently recommend you do is you should use the block structure, so the usual polygon tool, etc., in the Drone Harmony web or mobile application to model the building and to model level sets of the terrain. So if your terrain, usually around the building, you will not have too many different terrain, let's say, levels. So you can use other polygons to kind of outline the different height levels of the terrain around the building. So this kind of a workflow that you can, and a lot of our users are using right now to incorporate terrain when one is inspecting a building. However, in the future, and as I already said, we'll be working on many enhancements of terrain on flight where we'll enable these kind of combinations. So thank you for this question. What do you use to get building trees heights? And is it the drone itself, or something else? So this is another excellent question. So drone heights are usually inputted manually currently in the Drone Harmony application, as you've seen. And to know these heights is sometimes easy and sometimes a bit harder. If you inspect something like a cell tower, you will typically have some sort of CAD information about the tower. And if you have that kind of information, it usually tells you elevation above ground level, and that's a great source for information for heights. In other cases, if you use the height to if you use structure to outline an obstacle, in most cases, it's good enough to have a conservative estimate of the height. In particular, if you're talking about the tree canopy and you're sure that it's not higher than 8 meters, you can input 8 meters. If you need to be more accurate than this, you can use the drone to measure the height. So you can fly the drone, you can start the drone from the ground, fly to the height where you see the end of the tree canopy and read off the height. So this is definitely something that many users do in case they don't have either a good estimate or good information about the height of the obstacle structure that's being inspected. Okay. So what do you use to get a building tree height? I think this is the same question. Okay, so it seems that I have the same question twice. So with this, I'd like to conclude the Q&A session. I'd like to thank everybody for asking questions. And before I conclude, what I want to do is I just want to show you some of the resources that are relevant for this particular webinar. And I would also like to remind you that we will share the recording with everybody who's participated and registered, and you're more than welcome to share the recording with your colleagues. So let's just quickly switch over to my mobile browser, where I'd like to show you some of the other resources that you might find useful. So first off, I'd like to recommend you to take a look at our YouTube channel. On our YouTube channel, you'll find both recordings of old webinars as well as very nice videos that quickly introduce you to various features of the Drone Harmony application. In terms of working with terrain, we have a page on our webpage called droneharmony.com/help/working with terrain. You can easily find link to it from our website. This webpage outlines all of the workflow that I presented here, as well as all of the information about file formats that you'll need to know in order to work with terrain, including the coordinate systems of the georeference point clouds in which with which you can work, and so on and so forth. So take some time to take a look at this webpage in case you're not already familiar with this, to know what file formats you need to create and load onto your mobile device. And finally, I'd like to show you our website, droneharmony.com. Here you'll find a lot of additional resources, in particular user guides, tutorials, a link to our YouTube channels, and also some information about cell tower inspection, and so on and so forth. So feel free to take a look at our website. There's a lot more resources available here. Okay, so with this, I'd like to conclude the webinar. Thank everybody again for being here, and I will see hopefully many of you in future webinars. Thank you again.